Good afternoon, ma'am.
Good afternoon, ma'am.
Good afternoon,
Good
ma'am.
afternoon, ma'am.
Good afternoon.
Good evening, ma'am. Yeah. Good evening.
Good afternoon, ma'am.
Yeah, good evening.
Good evening, ma'am.
Good evening, ma'am.
Good
Good
evening.
evening, ma'am.
Good evening, ma'am.
Excuse,
Good evening, ma'am.
Good evening.
excuse me, ma'am. I have a simple doubt. Can I share my, can I share it?
Ma'am.
Is this a doubt?
Yes, ma'am. Means when we find the point biserial correlation, then there.
Yeah. So this is a revision session. So we're starting
Yes, ma'am. Like I want to ask, is the
three.
the
In the first
standard?
hour, we'll be focusing on week 3, and then we'll be.
Yes, ma'am. Please hear me out. Like the standard deviation will be always for sample, or we can use population standard deviation too.
It's always the population standard deviation, actually. If you want to find if you're finding the sample correlation coefficient, then you'll be taking the sample.
Ma'am, like in one of the tutorials, sir used sample standard deviation, and in the book which is provided by IIT Madras, so it's population
It's
standard
the
deviation.
population. Yeah, it's population.
So like the one which he did was wrong.
It might have been a question which specifically asked to do use sample, or it might have been a slightly different formula.
Sorry, ma'am,
But-
I can't hear you.
Yeah, it might have been a slightly different formula. They might have specifically asked to use the sample standard deviation, but ideally you're supposed to use the population standard deviation. And we'll start with the session now. So if you have any more doubts, you can ask when we're discussing the week 4 content.
Ma'am, I
Ma'am.
didn't get clear yet.
Yeah,
Hello, ma'am.
ask when we'll be discussing point biserial correlation.
Ma'am,
like,
what are the weeks we are gonna revise today?
now it's going to be 3 and week 4.
Okay. Week first and second are
Hello,
completely.
Week 1 and 2 will be done in another session.
Okay.
Yeah.
Please start the session because there is another session after it. So
Yeah,
please.
yeah.
Ma'am, we can take.
Ma'am, is this session only for week 1 and week 2?
It's week 3 and week 4. We are starting with week 3.
So ma'am, generally we should take population standard deviation, right?
Yeah, population, yes.
Okay, ma'am.
Are you audible, ma'am?
Yeah.
Can you one question, ma'am? Can you please one question?
So yeah, go on.
Two teacher A and B to check the mathematics paper and them by the student class 10, the mean and the population variance. Okay, ma'am. 20 paper check teacher. A teacher 20 paper checked 15 and 16 respectively for the remaining the 30 paper checked by the teacher B and the 16 and 25. What is the mean and
I think you should ask this in a doubt clearing session. We'll be having doubt clearing sessions tomorrow and day after. So
okay, thank you.
Yeah.
Ma'am, I guess you can mute everyone and start the session.
yeah,
Yes,
yeah,
ma'am.
I'm
There'll be
starting the
Yes, ma'am.
session. Yeah, I'm
Ma'am, that
starting.
will be great. Please.
Ma'am, also restrict the chat box activity if possible, just only to you, so that students can ask their doubts.
Ma'am, I just want to ask one thing, that tomorrow there is a mock discussion session, I guess. So which mock we have to do for that?
I think both the mock quizzes will be tested. Will be discussed.
Ma'am, this is a revision session.
So yeah, we're starting with the revision session.
Ma'am, please
start
the revision session.
Ma'am, can you explain the mock test?
It's already 6:12.
15%, ma'am.
Ma'am,
please
please
No,
for
no,
mute
the
all.
we're-
ma'am,
Start the lecture.
ma'am,
Yeah,
for
we're
the initial
starting the session.
Start.
ma'am, for the initial stage, please mute everyone so that no one can disturb in between, and you will not go out of the flow also.
Yeah.
Ma'am, start from week 4.
We'll do week 4 in the next hour. So in the first, initially, we're talking about the frequency table, right?
Ma'am, please see week 4 tutorial 4. Hello, ma'am.
Yeah, we are only doing the revision session. That will be done later. So if initially we're dealing with numerical data in week 3. So one way to describe numerical data is using frequency tables, right? So so we have 2 different ways of doing it. One would be for discrete data, and then we have for categorical, in interval continuous data. So for discrete data, if we have a data set which looks like so this would be to summarize this data set, we have to make a frequency table. So here number itself, and here we'll write the frequency. So frequency basically refers to the number of times that any unit or any data is repeated. So we have 1, 2, 3, 4, and 5 here, and 1 has frequency 2. 2 is repeated 3 times. 3 is repeated twice. 4 is repeated 5 times, and 5 is repeated twice. So this is how you'd make a frequency table for discrete. So this is very straightforward, right? But when we have continuous data, yes, you can unmute yourself. I'm not sure who raised their hand. Yeah, so now will be when another set of numerical data is continuous data. So in continuous data, it can take any value in any way. So it could take decimal value as well. So let's say we have data which looks like
And can you mute everyone?
Please mute everyone.
Yes, ma'am.
Yes, ma'am. Please mute.
yeah. So let's say we have data like this. So we can't look at the frequency of each of these because we could have any range of numbers, and if we have 17.99 and say 17.98, we would have, if we're looking at the frequency table like this, it would become a very long table and it wouldn't be very useful. So what we'll do is we'll make class intervals. And here we can look at this and we know that the minimum value is 10.2 and the maximum value is 17.98. So we can make class intervals which look like 10 to 13. And the frequency for this would be from between 10 to 13, not including this. We have 10.2, 11.32, and 12.5. So we'll have 3 here. And we can do this using tally marks as well. So for 10.2, so that's 10.2, 11.32, and 12.5. Between 13 and 16, we have 15.23. And in here, we won't be including 16. So it would be like 13 to 16. So we are not including the number 16 itself. So this 16 would come in the next class interval. So here we'll have 16, 17.99 and 17.9. So this is how you would make a frequency table. And since for the class interval will be, since this is a whole interval, for all calculations, we'll be using something called a class mark, which would be the middle value of this. So the way that we calculate this for a range A to B is we find the class mark as A plus B by 2. So here it would be 10 plus 13 by 2, which is 23 by 2, which would be 11.5. Similarly, we can find the class mark for B as well to find the calculate. So I think that all there is in the first video. So is there any doubt in this topic?
Yes, ma'am.
Ma'am,
Ma'am, actually,
like-
the class width of the last observation is. Can you show me the screen? Yeah. So the class interval is 10 to 13 and 13 to 16, and it's 16 to 20.
Yeah, this should be 19.
Yeah.
ma'am, why do we choose 10 to 13? Why not 10 to 15 or 10 to 14 or 10 to 17?
We can do that. This depends upon the discussion of the person doing it. So I just chose 10 to 13 because so that we can have a more even. Here it's only from 10 to let's say 18. Right?
So ma'am, it should be
So-
between range 2, 3 or like the if we want like correct answer, or it should be.
No, it need not be necessary like that. The reason that I chose this is because if it was 10 to 15 and 15 to 20, then we would then it would represent the data in we won't be able to represent this data properly. That's what I felt.
Please.
Yeah. So the class width depends upon how you prefer. So it should be a good representation of the whole data set. And it shouldn't be too big and it shouldn't be too small either. So yeah, and we can find the relative frequency also. So we can find the relative frequency as we'll find the total frequency here. And so the total frequency here is 7. And the relative frequency here would be 3 by 7, 1 by 7, and 3 by 7. So the formula is relative frequency is equal to the frequency of that particular interval divided by the total frequency. And to construct a histogram, we'll use the same class intervals. So here we'll I think so from here 10 to 13 we'll have frequency of 3, and 13 to 16 would be 1, and 16 to 19 will have, and we can find the histograms of any data set like. So I think that's all in the first. Should we discuss this?
Was this relative frequency partner?
Sorry?
Was this a relative frequency partner?
No, this was the frequency.
Ma'am, median. For that, we have to find that cumulative frequency also.
Yeah, the median and will be this. That's a weak 4 question.
Now we are seeing that this frequency. Ma'am, now this exercise is a frequency chapter.
Yeah, we are looking at the frequency, the first video.
Okay, thanks.
Yeah.
Excuse me, ma'am.
Yeah.
Ma'am, a small question regarding histogram. Can you show me the picture which you have drawn before, like the graph you have drawn before, ma'am?
Yeah.
If we think that this question is not related to the histogram we drew, if I have a frequency between 0 to 5, which is 2, like would the graph you're drawing lie on y-axis? Like would it touch the y-axis?
Yeah, it would touch the y-axis.
Ma'am, can you show?
Yeah, cool. Thank you. Yeah.
Hello, ma'am.
Ma'am, can you go previous slide?
Ma'am, how to find median and mean of continuous?
That's a weak 4 portion. We'll be discussing it then. So now we're looking at the stem and leaf plot. So the main thing to notice in the stem and leaf plot is first thing it should be in ascending order. And here we'll have a stem and a leaf. And usually when we have a data set like we would take the digit on the tens place as the stem, and the leaf would be the digit at the ones place. So as the stem, we have 1, 2, 3, and 4. We'll write the stems like this.
Please.
Yeah. And we'll be using the digit at the ones place as the leaf. So for 1, we will have a leaf as 9. For 2, we have 0, 0, 1, and 2. For 3, we have 0 and 5. For 4, that's 5 and 9. So this is how you would represent a stem and leaf plot. So this is the stem, and this is the leaf.
Ma'am.
Yeah. Any
How to
doubts here?
represent? Yes, ma'am. How to represent 0 to 9 numbers in step leaf form, ma'am?
Yeah. So if we had a number 0, 0, 9 here, we would have a stem.
And how would you represent 12.5 if it is in decimal?
Yeah, so first we'll discuss this. So 0, 9 would have the so 9 will be representing it as 0, 9. So 0 would be the stem and 9 would be the leaf. And if it was let's say 19.5 instead, you can just represent it.
But, ma'am, 3-digit number?
Ma'am, what?
3-digit numbers. In that case, we can't take the tens place as a stem. We'll have to take the we'll have to include the 100th place as well.
Ma'am, what if the data occurs twice? How do we do that in that case?
Sorry?
If a data occurs twice, how do we do that?
We can just write it here. If 22 was repeated twice, it would be represented here.
Can there
Thank
be
you, ma'am.
values in the stem and leaf plot?
Excuse me, ma'am.
And can there be decimal point, like decimal
Yeah,
values?
there can be, yeah.
Ma'am, please represent one as example for 3-digit decimal.
Guys, why are you moving out of syllabus?
Yeah, that is out of syllabus. Also,
That's not out of
we
syllabus,
don't
ma'am.
really
What is the
We have
difference
a
between a histogram graph
we
and
have
a
a mock question
Pareto
of that, ma'am.
Mock 1 and mock test 2 is
Don't disrupt the class.
That's
a
not
lot
out of
of you are
syllabus actually.
speaking at
It's
the
mock
same time.
question.
Okay, but that look at.
Ma'am, please
it's about
continue
100
according to the syllabus.
Yeah, we're only revising here. So
Ma'am,
if you
please
have more
elaborate.
doubts, please join the doubt clearing section. Because we're running out of time, we only have 1 hour to revise this.
Excuse me, ma'am.
Yeah.
Ma'am, what is the difference between histogram graph and Pareto graph?
Yeah, histogram is for continuous data, whereas the Pareto chart is more, it's more closer to a bar chart. So we would use it more for the categorical data. So now we'll move on to the descriptive. Yeah.
Ma'am, in student and late, why is it taking 9.5?
If we were just talking about decimal points, if it was 19.5, we would just represent it as 190.5. So now look at the descriptive measures for measuring or describing the data. So we have two ways of doing it. One is central tendency and one is dispersion. So the central tendency would represent any value which is in the middle of the data set, like the mean, the median, and the mode. Whereas dispersion would represent how spread out the data is. Like the range will tell you what the minimum and the maximum value would be. So the most common way of measuring central tendency is mean, and the formula for mean is simply mean is the sum of observations divided by the number of observations. And so for data sets like this, it's we'll just simply add all of these up and divided by the number of observations. So would that be a very simple way of doing it? No doubts until now, right?
No,
Yeah,
ma'am. It's all clear.
Yeah, so now we'll look at discrete data set when some values are repeated. So in that case, we would have a frequency as well. So first we'll make the frequency table. So here we'll put 1, 2, 3, 4, 5 and find the frequency. And the formula here is summation of fi xi divided by summation fi. That is summation fi into xi divided by summation fi.
Ma'am, your voice is breaking.
Ma'am, you are
We
having
discuss how
network
to do
issue.
it for
Ma'am, your
discrete
network
data.
is low, ma'am.
Am I audible now?
Ma'am,
Yeah.
now it's okay. Continue.
Yes, ma'am.
Okay, so we discussed how to do it for discrete data. Now I'll look at continuous data. Yeah.
I have a doubt, ma'am. Ma'am, for this group data, we need to take out this midpoint.
Yeah, the midpoint is the class mark.
Yeah, for the previous example, we don't need to take out midpoint.
No, this is we're given only one value here, so there's no reason we have to find the midpoint.
Okay, ma'am. Means when there is a class interval, then you need to take out the midpoint.
Yeah, because we can have any value in this range, so we need to find out what the midpoint is. So we're approximating all the three values in between 30 and 40 to 35. That's what we're doing here.
Okay, ma'am.
Yeah.
Okay, ma'am.
Yeah. So when we have continuous data, instead of this xi, we will be using the class. And to find the class mark, we will be using the formula. To find the class mark, we'll be using the formula a plus b by 2, where a is the lower limit and b is the upper limit. Now, if we're adding a constant and multiplying a constant, the mean will change. So if we're adding a constant, so if we have a data set which looks like x1, x2, x3, x4, and so on, and the new data set looks like x1 plus c, x2 plus c, then the new mean will be calculated as x1 plus c plus x2 plus c and so on, divided by, here we have 4 into 4 values, so divided by 4. And here we'll have 4 different c's, right? We're adding 4 c's up. So we can just group the c's together. And now if we just break this fraction, we'll get x1 plus x2 plus x3 plus x4 by 4 plus 4c by 4, which is c. And as we know, this part is the old mean, right? So this would simply be x bar plus c. So the new mean, if we're adding a constant, would be the old mean plus the constant. And similarly, if we have the new data set, it would, if we're multiplying c to all the values.
Excuse me, ma'am.
Yeah.
I have a question.
Yeah, go on.
The previous slide, when you calculated the mean of the continuous data.
Yeah. We didn't calculate it. I just gave you the.
Yeah, the formula actually.
Yeah.
You said that for continuous data we use that formula. I mean, is it for continuous or is it for when you have class interval? Because sometimes for continuous data you can have actually written without the class interval. For example, let's take weight of people. Weight is actually continuous, but let's say we do not have written in class interval. Then actually your voice is breaking.
Yeah. If you have continuous, okay. Is it better now?
Yes, ma'am, it's fine.
Yes, ma'am.
Okay. So if we have multiple data points which are continuous, we'll be usually making class intervals. So for continuous data, usually this would be used, this formula.
All the time when you have continuous, or only when you have the interval? I mean interval.
Only when we have the interval.
Okay.
But
Meaning,
yeah.
Yeah, when you have continuous, but it is written in discrete fashion, then we use the discrete one, the formula for the discrete.
Yeah.
Okay, thank you.
So now I'll talk about multiplying a constant. So the
Ma'am,
new mean here
I have a
would be,
question.
yeah.
Ma'am, in the while adding a constant, if it is given x to the power means x to the base n, so for that situation we have to common the constant, right? We can't count the base, no? For that means it is either 4c or.
Yeah, so you're saying if we have n observations.
Yeah, correct.
Yeah, in that case, would be we can just simply replace n in the place of her. So here we would have n c's, so this would become nc, and here c would again be c.
Ma'am, your voice is breaking.
So we would
Yes,
again
ma'am,
have
it's lagging.
okay.
Is the constant x1 plus
Ma'am, your voice is breaking.
Yes, ma'am.
Yeah, 1 second. Ma'am, are you talking?
Yes, ma'am. Now your voice is little clear.
So for multiplying I'll take a general case. So if we have n observations, then the new mean would be this. And in this case, we can just take C common and we would get
Ranjan, please mute yourself.
and here we can just take C common. So we would get C into X bar.
Ma'am, I ask.
Rajan Paswan, please mute yourself.
Ranjan Paswan, mute yourself.
Yeah, I have muted everyone.
Ma'am, I have a doubt.
Yes,
Ma'am,
go on.
please repeat once more,
Um,
ma'am, because of voice disturbance, I couldn't hear.
Yeah, so the new mean, if we're multiplying it, it would look like Cx1 plus Cx2 plus so on until Cxn divided by n. So in this case, since every number in the numerator has C, we can just take C out and write C into this. And as you know, this is the old mean. So the new mean would simply be C times the old mean if we're multiplying C to all the observations.
Okay, thank you.
Ma'am, shall I continue with my doubt?
Yes.
So basically, usually in the questions, it usually comes that they are only changing one of the variables in the equation. So in that case, what should be the formula? 1 by C or into C by n or what?
No, C is the constant that we're adding or multiplying. So if we're changing one observation, then it would be an entirely different formula. So we would just have
Ma'am, your voice is being distorted.
okay.
No, it's fine.
It's fine.
No, ma'am, it's
Yeah,
fine.
it's full. Yeah.
Ma'am was not speaking.
Fine.
Ma'am, you will not audible.
My internet, it's all the best. So I think I'm not sure what the problem is.
Ma'am, you are audible.
You are
Yeah.
audible.
So if we're so for the mean, if only one value has changed, let's say we'll only look at 4 data points, and the H3 is basically, let's say for new we have H3 is supposed to be, let's say, some number m. Then old mean, you'll have to calculate it by hand basically. So if we know that the old mean is X bar, then the new mean would be the summation of the correct observations divided by n, and n will usually be given to you. So the sum of the correct observations, we can write it as what it's supposed to be is this, but what we have, we can just add and subtract the wrong value. So if we're taking this, if we're rearranging it, we'll get this. So we know that the old mean is X bar, so this would be X bar. So generally we can just write it as the new mean would be the old mean plus the correct value minus the wrong value divided by n. And these three values would be, all these values would be usually given to you in any question.
Ma'am, n
So-
will be the number of observations.
Ma'am,
Yeah,
why
n
are
is
you
the number
taking
of
minus x3?
we added and subtracted H3 here, so we can get the old mean in the right hand side.
And what in the case of multiplication? It would be just a multiplication. That's it.
Yeah, if we're multiplying a constant, then it would just be C into X. The new mean would be C into the old mean. Now we'll move on to the median and the mode because we're running out of time. The median is the data point, which will divide the data set into two halves. So the the steps is pretty straightforward. So if the number of observations is odd, then you'll have to find n plus 1 by 2. And the observation at this point in the order data set is the median. And when it's even, we'll have to find the average of the two values at the n by 2th position and the n by 2 plus 1 position.
Now the previous one you showed it's only for discrete data, right?
This
The
one.
mean.
Yeah, this is the formula for the discrete data. And one thing to note, which everyone might forget to do in the questions, would be to arrange the data in increasing order. So do be careful about that when you're solving the question in the qualifiers.
Ma'am, can you show me please previous whiteboard question?
Yeah, we were just dealing with the correct observation and the wrong observation. Yeah. So
thank you, ma'am.
Yeah. And with respect to outliers, we usually say that mean is the most sensitive, and then it's the median, and mode is the least sensitive for outliers.
Which is the most sensitive?
Mean is the most, and mode is the least. And to find if we're adding a constant or multiplying a constant, the median also will have the same effect. Because we're only looking at
class interval and midpoint.
It's a class interval is the range. It would be given like this. And class mark would be given by the midpoint. And this is the same as the midpoint.
Ma'am, can you please explain the outliers?
Maybe you can join one of the doubt clearing sessions for that, because we're running out of time to discuss week 3 portions. We'll have doubt clearing sessions, I think from day after. Yeah, so if we're adding a constant to all the data points, then the new median would simply be old median plus the constant. And if we're multiplying it, then it would be old median into the constant. This is when we're adding one value to all the data points, and this is when we're multiplying see what's all the data.
Excuse me, ma'am.
Yes.
Ma'am, in the class interval, the median will be the midpoint or the whole class interval? We'll consider that.
We would consider the midpoint, not this.
And same for the mode?
Yeah.
Okay, ma'am.
Yeah.
Excuse me, ma'am.
Excuse me, ma'am.
Yeah.
Ma'am, when we do addition and multiplication while finding a new median.
This is when we're adding C to all the points.
Excuse me, ma'am. In case of
Your voice is echoing out loud. I can't.
Ma'am, median is not affected
We
by
don't have
outlier.
time for doubts right now. I'm sorry. So we'll go on with the session. If there's time at the end of the session, you can ask your doubts.
Ma'am, what will happen if I change some values in the dataset and then try to find the new median?
You'll have to start from scratch and find the new median.
Okay.
Yeah. So mode is the the data point which has the highest frequency. Basically means it should repeat the most amount of time. And the properties for mode when you're adding a constant and multiplying a constant is the same as the median and the mean as well. So if we're adding C to all the data points, then the new mode would be the old mode plus the constant. And if we're multiplying a constant to all the data points, then the new mode would be the old mode into the constant.
Hello, ma'am.
So
Hello.
yeah,
Ma'am, like the formula for adding a constant or multiplying a constant is there.
Excuse me, ma'am.
yeah, it would be the same as this. So
Okay, ma'am.
if we're adding C, then the new mode is old mode plus C. And if we're multiplying C, then the new mode would be the old mode into C.
Ma'am, what in case only one value changes?
For mode. You'll have to look at the data set again. If the frequency of that data point, which is the highest, remains the highest even after the change, then the mode won't change.
Can you explain the 15th question of mock test to do, ma'am?
No, this is only a revision session. No, the mock test discussion is tomorrow. So now we'll look at the measures of dispersion.
It should not be discussed, Ramam, actually.
Yeah, it should not be discussed now. So dispersion will measure how spread out the data is. So the first way of doing that would be we can find the range. So the range is simply the maximum value minus the minimum value.
Excuse me, ma'am. Ma'am, what
Yeah.
is measures of dispersion?
I can't hear you, sorry.
Yes, ma'am. What is measures of dispersion?
Yeah, so this measures of dispersion is measuring how spread out your data is. Like how far away from the central tendency the data is and stuff like that.
Ma'am, I think it's basically read out the data.
Sorry?
Ma'am, could you please explain once?
I can't hear you properly.
Ma'am, can
She
we
is
say that
asking to
opposite
give
of
you
measure?
an example of means or dispersion of data, I guess.
Yeah. So
Yes,
one
ma'am.
way to do that is to find the range. Right? So the range for an example would be we're just going to find the maximum value, the minimum value, and find maximum minus min. That's an example of measure of dispersion. So we're finding out how spread out the data is.
Ma'am, my question is what is measures of dispersion?
Yeah, so it's a measure of finding out how spread out the values are. So if in this way, in this data set, the values are not spread out at all, right? It's all the same. Here there is some variation. So there are values from 1 to 5. So you can say this data is more spread than this data set. So the one way of measuring that is called measure of dispersion.
Okay, thank you, ma'am.
Yeah. So range is obviously sensitive to outliers. So if we had data set 1 to 5, and then if you had 1 to 5 and another value which is like 1 million, then the range would be very high, even though there's only one very high. Another way is doing that. This is the most popular way of finding the measure of dispersion, which is variance. Yeah. So to find the variance, we have the formula as population variance is
Can you show the definition of variance?
Variance is just a way of finding out how spread out from the mean it is. So we're finding the sum of the deviations from the mean, the squares of it.
Ma'am, what does it mean by range is sensitive to outliers?
If we have a data set which looks like this, the range would be 5 minus 1 equal to 4. But if we have a data set that looks like, then the range would be a very high value. And that would basically tell you that the data set is very spread out, but it's not really the case because there's only one outlier. So that's what it means. So here it would be a very high value, right? Range would be this value minus 1. So this would be much higher than 4, even though only one value is very high. Yeah, now
Let's
the
use some
variance.
examples for sample variance and the sample standard.
Guys, it's already 7 and we still have to discuss about the fourth week. So please don't ask else.
Yeah, and the formula for sample variance is just n minus 1. We'll just use n minus 1 instead of n. This is the only difference between the population and the sample variance. So I think this topic would be pretty important for the qualifiers. So do make sure you know how to do it.
If a value is changed in
and
the
then-
data set, how will we find the new variance using the old one?
It would, I think that would be a very long process. I think it would take about 10 to 15 minutes to explain that.
Can you briefly explain it?
Can you explain in a last?
Maybe you can
in the end
join
of the
the
session?
doubt clearing.
Which all topics are
Can
important
you
for
join,
qualifiers from stats?
Yes, ma'am.
all the topics are equally important. You have to. We're discussing this now. Let's just focus on this. And the next way of measuring dispersion is a standard deviation, which is simply the root of variance. And we're doing this because in this, the unit would be, if our unit of x is in kg, then this would be in kg square, which does not make any sense. So to bring it back to the original unit, we are just finding the square root of variance. So standard deviation and variance are pretty important.
Ma'am, your voice is lagging.
So you can,
Yes, ma'am.
1 second.
Excuse me, ma'am.
Your video is paused.
Yes, tell me.
Yeah, is it better now?
Yes, ma'am.
You can
Yes,
which all
ma'am.
topics are important for
So so this is all about
Your voice is still
variance
lagging, ma'am.
Ma'am, your
Ma'am, your
network
voice is
is
being distorted.
slow,
Ma'am,
ma'am.
your audio is distorted.
Ma'am, your voice is lagging.
Yes,
Ma'am,
ma'am.
your voice is lagging.
Ma'am, for me, good ma'am.
Ma'am, you explain direct formula, ma'am, but IITM.
the Wi-Fi. Yeah, so the next one is percentiles. So the percentile, if we're finding, let's say, the pth percentile, what it means is in a data set where this is like, if we're arranging the data set, then when we're finding the pth percentile, it means that p% of the data lies before it and 100 minus p% of the data set lies after. So this is what we're doing when we're finding the pth percentile. And the algorithm to do it is we'll find the NP value. And I think the algorithm is given here. Yeah. So we'll
How
find
P
NP.
in every data set.
Sorry?
How to find P in the data set?
That won't be given in the data set. It'll be asked in the question itself. So if they're asking you to find the 50th percentile, then P is basically 50 by 100. So it would be 0.5.
Ma'am, actually, in the question given in the graded assignment, there's a one means it doesn't given the P's value.
No, P won't be given to you. If you have to find the 50th percentile, then you have to calculate P as 50 by 100. If you're finding the 78th percentile, then P would be 78 by 100 or 0.78. And then you'll have to find the NP value. So N would be the number of observations. And if NP is a decimal, then you'll have to use the greatest integer function. So that basically means you'll have to find the value, which is, we'll have to find the integer, which is just above the, so if we have, let's say like 2.6, then you'll be approximating it to 3. Even if it's 2.4, you'll have to round it up to 3.
Ma'am, can you
What
repeat
about 2.1, ma'am? Yes, ma'am.
Yeah, so after we find NP, if NP is an integer, we will have to find the average of the NP and the NP plus 1 stack.
Excuse me, ma'am.
So this would, yeah, do the
I
number.
have a question, ma'am.
How to find
Explain
N?
to what?
Maybe you can type it in the
Ma'am?
chat box.
If NP is not an integer, then what do we do, ma'am?
And if NP is not an integer, then you'll have to find the integer, which is
Greatest nearest would be.
So, ma'am, what about 2.1? What will be the N there?
3.
3. And 1.9 is 1.
No, 2. 1.9 is
2.
2. It will be the second.
Ma'am, we lost you.
Next highest
Yeah.
to a specific.
So like if it's 2.6, then you'll have to round it up to 3. Even if it's this does not follow the normal rule. Yeah. No, 1.9 is still, you're always rounded. Yeah, all that. Yeah, it'll be the second.
And ma'am, 2.5.
Same 3.
It will be round up to 3.
The next greatest integer.
You have to consider the next greatest integer. Yeah, yes.
So
Yeah,
basically,
but
once
to
the
find-
answer comes in point, we have to take the next greatest value. Right?
Yeah, the next greatest.
Yeah. Don't imply the greatest integer function. It's different. Ma'am, if it would be 2.1, then still we have to.
My Wi-Fi is very weak. Right?
Next.
Ma'am, if it will be 2.1, then the N will be 3, right?
Yes.
Yes,
Okay.
the next integer.
Okay, thank you.
Ma'am, if we are not given N or the data set, and suppose if we are given only the Q1 and the Q3 value, can we safely say that Q2 would be around Q2 value plus Q1 value plus Q3 value by 2? Can we say something like that? Yeah.
Ma'am is having network issue, I guess.
For
Sorry?
n, you can count number of observations.
So if we are not given N and we don't know the nth position, and we are only given, say, a box plot with Q2 value and Q3 value, Q1 and Q3 value, and we have to find the 50th percentile, can we safely take the average of Q1 and Q3?
No, not
Yes, we
necessarily.
can.
It may
And-
lie between Q1 and Q3, but the average will not be the Q2. That's the 58%.
Yeah, it is not necessary that it will be the average.
It definitely will. It will lie between in Q1 and Q3.
It may work if the data is in class intervals.
So if we don't have the nth position of or the data set, then there's no way we could find the mean.
No, the data set must be given. Then only we can say
the observations will be given.
This is from mock now, right?
No, sometimes the observation is not given if you refer to the mock test or something. So we might have to make some assumptions. So I guess the mean will lie between.
Then the options will be in that.
Where is ma'am?
It's
that
according to that
suitable.
question. Yeah, suitable.
So we can. So do we also assume that the mean will fall between? I mean, we say the mean will fall between the Q1 and Q4 value, right? Q3
No,
value.
mean will not fall. Median will be between them, but it is not necessary that it will be the average. But if there is some options suitable for that, then we can opt that option.
Okay, so the median will fall because the median is the 50th percentile, so it will fall between the Q1 and 25th.
Median is basically the Q2.
Median is
Q2
15
median.
percentile, 50th percentile.
Yeah,
Second quarter is the median.
Yeah, median is the 50th percentile. Also, so my internet connection is very weak right now, and week 4 will be taken by Abhilash. So as I wasn't able to complete percentiles, and my internet is not very strong right now, he will be continuing from percentiles.
So when will that be?
Right now, he will be joining in 2 minutes.
Fine, ma'am.
Thank you, ma'am.
Hey, I want to add something that in the point that in a median, okay, 50 percentile is equal to means maybe second quartile, isn't it?
Yeah, 50th percentile.
Yes.
And
median.
the middle value of and also the middle value of box, isn't it?
Yes.
Yeah.
These three are same.
Yeah, these 3 are the same. Median is the same as the second quartile, and the 50th percentile.
Excuse me, ma'am. Ma'am, may I ask
Ma'am,
a
we will
question?
not. Ma'am, week 4 will not discuss today.
Week 4 will be discussing it in 2 minutes. Abhilash will be taking the session. He's here right now. He will.
Ma'am, we need a separate session on box plot and all the concepts relating to it. Is it possible?
That you ask in the TA section. That will be good for you.
Yeah, you can join the
The TA session. It's not, most of the times it's not available. Keep waiting.
We can't join them. They don't accept.
Even the 7 to 9 session.
You can ask when ma'am or sir will explain. Okay.
Ma'am, you are also our TA, no?
Yeah, we are the TA. So are you not able to join the 7 to 9 sessions also?
No, ma'am.
Okay. Okay, I wasn't aware of this. We'll talk about this.
Ma'am, I am unable to join any sessions. I talked to Deepak sir about that too.
Okay, I see. Yeah, I wasn't aware of this actually. I'll bring this up with the principal.
Ma'am, actually, the TA sessions for stats
Provide
and for
important
CT, the
topics
links are changed.
qualifier.
And it is not still updated in the TA, means the link that is.
Okay. Okay.
But in Google Calendar, TA session is every day.
Yeah. Join I think the one on the form is different. The
Yes,
one
ma'am, but
on,
nobody lets us in.
Yeah, I think you'll be joining the wrong session.
Asked to join there,
So,
but then nobody lets.
yeah, the one on the Google Sheet thing, it's wrong because we updated it after that. So you'll have to add the calendar.
Ma'am, I added that yesterday too, but to no avail.
I also added recently, but I couldn't find any TA session on statistics recently. That's
Ma'am, we
why
are having only office sessions.
Is it office hours?
Yeah, we have office hours from 11 to 12 and 3 to 4, and you'll have open sessions by the TAs on 7 to 9.
Guys, you people do realize that we have another session from 8 o'clock.
Yeah. This is just a break. This now 8 to 7 to 8 will be week 4. Abhilash is taking it now.
Excuse me, ma'am. Ma'am, I have a doubt in some particular data in which the class width is given, means for example 0 to 10 the frequency is given and 10 to 20 the other frequency is given. How to find out the standard deviations and
Hello.
Maybe.
What is the
maybe
difference between the testing octars and this differentiation?
anyone have gone through mock test? Okay, 1 and 2.
Yeah, one is over.
Yeah, 1 is very tough, man. I have gone through today, but 1 is very tough. I did not able to. I have not able to solve 1 or I have solved 1 or 2, but it was very tough.
Yeah, and
Okay, so good evening, everyone.
Good evening, sir.
So, am I audible?
Good evening, sir.
Yes, sir.
Yes, sir, you're audible.
Okay, sure. So, yeah, so we will complete from week 3 the last few topics, whatever is left, and then we will switch to week 4.
So first tell important topics from all weeks.
Okay, so one by one we will take. So let me share my screen first.
Ma'am, sir is left.
He's in the session. We're facing some technical issues right now. We'll fix it in 2 minutes.
Ma'am, what happened, ma'am?
Yeah, Abhilash is facing some technical issues. He'll be joining in.
Ma'am, your voice is now audible, so you can teach us like week 4.
Yeah, no, he's supposed to take week 4. So, he'll take it from my laptop. Just, give us 1 minute.
By 9, ma'am, today?
No, right now.
Ma'am, I think we can take a separate session for week 4.
Then again, it will get delay.
Yeah, just 1 minute.
Who's that guy doing that?
I guess we are happy to wait because we have already scheduled this meeting, so we are happy to wait for that.
Okay, so am I audible now?
Yes, sir.
Yes, sir.
Okay, so
Yes, sir.
so yeah, we'll start then. Yeah. Okay, so we were in week 3, right? So okay, I haven't shared my screen. Oh, okay, is my screen visible to you?
No, sir.
No, sir.
No, sir.
Okay, wait, let me share my screen. Is it visible now?
Yes, sir.
Yes, sir. Yes, sir.
Talk about first percentile, right? So we were okay. So let's talk about quartile, percentile, IQR, and all such things. Quartile, percentile, and IQR. Okay. So quartiles, what happens is if I take this, so there's this thing called first quartile. So it is 25th percentile, right?
Yeah.
Yes, sir.
Yes, sir.
And then there is this Q2, which is your 50th percentile, which is also known as median, right?
Yes, sir.
Yes.
And then there is Q3, which is your 75th percentile.
75.
Yeah. So what quartile does is it divides the data into 4 parts. As you can see, this is one part of your data. This is another part of your data. This is another part, and this is another. So what quartile does is it divides your data into 4 parts, right? This is the basic meaning of putting in by quartiles. So as you can see, there are 3 points. So 3 points divides 4 equal parts, right?
Yes, sir.
So this is one part, this is another, so that's how the quartiles divides your data. Now the thing is, if I give, let's talk about percentile.
Percentile divides 3 parts, sir.
No, percentile. No, that's quartile, right? So what quartile does is, this is your first quartile, this is your second quartile, this is a third quartile. So these 3 points divides your data into 4 equal parts. That's the basic meaning of quartiles. Is it clear?
Yes, sir.
Yes, sir.
Yeah. So what percentile is? Okay. So percentile, what it does is, if I say 50th percentile, what does it mean?
Second
It means
quarter.
it is this second quartile. Yeah. What it does is it divides the data set into 2 parts. That is, one part that is 50% will be the data on your left, and another 50% of the data will be towards right. So it divides the data into 2 parts, right? So if I give you 75th percentile, so what will it do? It will divide the data into 2 parts. So 75% of your data will be towards your left, and there will be 25% of your data into your right. So in exams, for instance, there is this exam JEE Mains where the result comes in percentile, right? So you must have heard I got something 99 percentile. So what does it mean?
99%.
You perform better than 99.
Yeah, 99% children or students are behind you, and 1% of the students are ahead of you. That's what it means, right? It divides the data into 2 parts. So 99% is to your left and 1% is to your right, which means 99% children are behind you and 1% are ahead of you. So that's what percentile does.
Yes, sir.
Okay, so
isn't it that it's percentage, right? Not percentile. Percentile is
no. Percentile is basically, see, percentile is that's how we interpret, right? So if I tell you there's 35th percentile, so it's basically that part of your data. So this is your 35th percentile. So this observation will divide the data in 2 parts. So 35% is this, 65% is this. So it divides the data. That's what it means, percentile. Right?
So like, can we say
if I give you an example, let's give you an example. What we are saying is, let's assume height, like height of person. So if I say the height of a person is, let's assume it's 70th percentile is. So if I interpret it, it means 70% of the people is smaller than you and 30% of the people are taller than you. That's what it means. It divides the data into 2 parts, right? Percentile is basically that point which divides the observation or the data set into 2 parts. It's that part of the observation which divides the data. That's what the, in simple term, that's what it means, right?
Yes, sir.
Okay,
Yes, sir.
so maybe we can.
Very good explanation, sir. Thanks.
Yeah, so maybe we can take an example. Let's take a data set. So let's assume we have a data set, small data set. Let's assume 1, 3, 5, 7, and 9. So if I tell you what is the, let's say, second quartile, what is the second quartile here?
First of all, descending order.
It's in ascending order, right? Yeah, 5 is your second quartile, and it is also median. So what is median? Median is that middle value which divides the data set into 2 equal parts. So as you can see in the data set, this is your middle value. It is dividing the data into 2
Sir,
equal parts.
how 5 can be the second quartile? So can you explain?
That's because n is 5, no? So how do you find quartile? Let's talk percentile, right? So what we'll do is you will first arrange the data in ascending order, right?
Yes.
Yes. So the data is already in ascending order 1, 3, 5, 7, and 9. Next, what we will do, you will find the value of n. So how many observations are there? 5 observations, right?
5.
Right. Next, you will find the value of p.
Sir, here
So if
then we will multiply p is equal to 0.5, then 0.5 into 5.
Yes. If I am telling you, let's calculate Q1, which is 25th percentile. It means the value of p will be 25 by 100, which is 0.25, right? So you will find the value of np. So what will be np? 5 times 0.25.
1.25.
1.25. So if it is not an integer, this is a decimal value, what you will do is you will take the next integer value, which is second, 2, right?
How do you, sir? Could you,
Sorry?
0.
If it was integer.
0.25.
See, this is, yeah, this is because this is 25th percentile. So if I tell you calculate, let's assume 37th percentile. So in that case, what will be your p?
P is
It will
equal
be
to
37 by 100, right? It is 0.37, yeah.
Yeah.
So now if you get a non-integer, which is 1.25, in that case, you have to take the nearest integer, which is 2. Your second, these 2 represents the second observation will be your first quartile. So what is the second value in the observation? 3, right? So Q1 will be 3. Now, if I tell you, let's calculate Q3, what will you do? What is P here?
75 upon 100.
0.75, right?
Right.
Yes.
So next you will calculate NP. So it will be 5 times 0.75, right?
1 point.
So it will be how much? 3 point something. You will take the next integer. It will be 4, right?
0.75.
Yeah. So fourth observation will be your third quartile, which is your 75th quartile percentile. So it will be how much? It will be 7, right? Because your this value is your Q3.
Sir, 0.35 or 3.97. So 3.97 will be 4 and 0.35 will be 1, right?
If you get 3.1, if you get 3.3, if you get 3.9, anything, you'll take 4.
Thing you can take. Yeah.
Yeah. The next greatest integer you will take.
Sir, what if the nearest integer?
Sorry?
So what if the NP value turns out to be
Yeah.
an integer itself?
Yeah, if it is an integer, let's assume if it is an integer, suppose we get an integer, let's assume 4. Then in that case, what we will do is you will take the fourth observation and you will take the fifth observation. You will add them and divide it by 2. That will be your percentile value. Yeah. So I think this is pretty straightforward, right?
So, but if we get values from 3.1 to 3.9, then the 31st percentile to 40th percentile will be the same observation.
So if you get NP value anywhere between this, you will take the fourth observation, right?
Yes, so therefore 31st percentile to 39th will be same observation, right? Which is the fourth observation.
That you have to calculate depending on the data set, right? But the thing is, you will take the fourth observation with your, yeah.
Sir, in what scenario will such a situation come? Can you give one example?
Excuse me, sir.
Yeah.
Sir, detailed solution are already done in many sessions. So if you quickly revise
okay,
whole
sure.
concept,
Week 4 will be
yes,
important, right?
We
Week
have
4
only 30 minutes.
Yes, sir.
Okay, sure. We can go ahead.
Because
Okay,
there is another session after it.
Okay, sure. Let's then go ahead and maybe I'll write down what is IQR. It is third quartile minus your first quartile, right? So what IQR does is, if this is your Q1, if this is your Q2, and this is your Q3, IQR basically observes the variation between this data. So if these points are dividing the data into equal parts, so this is your 25% of the data, this is your 25%, because it is dividing into equal parts, right? This is your 25%. So what IQR does is it talks about this data, Q3 minus Q1. What does it mean? It's basically talking about the 58%, middle 50% of the data. IQR talks about the variation. So this Q3 minus Q1 basically implies that we are looking at the variation between the middle observation. That is the middle 25 and this 25. That is the middle 50% of the data IQR represents. So I think you know how to calculate IQR, right? Just difference between Q3 and Q1.
Yes, sir. Yes.
And let's quickly talk about outliers. So for outliers, you just need to calculate Q1 minus 1.5 times IQR. Anything that is less than this value will be your outlier, and anything which is greater than Q3 plus 1.5 times
Q1 equal to Q2, sir.
Q3 plus
any value with this is how we will calculate.
this is outlier.
Anything which is less than this and anything which is greater than this one will be an outlier. So I think this is pretty straightforward, right?
Yes.
And
Yes,
one
sir.
of you was confused between box plot. So maybe I'll tell you what is box plot. So box
Page
plot
one-
is
one time,
basically this is
Repeat again, sir.
so this is box plot. So this value is what? This is your minimum value, right?
Yes, sir.
Minimum value.
And this value is your first quartile.
Q1. Yes, sir.
This is your middle
Q2.
Q2, which is median. And this value is your 75th percentile, and this is your maximum.
Yes.
So if a box plot is given to you, so from that you can infer this values you can find out. Okay.
5 number summary.
Yeah, 5 number summary is what we call this. So let's go to week 4 then, right?
Yes.
Hello, sir. Sir, can you scroll, sir?
Okay, sure.
So how do you find outliers from this graph?
Outliers is this. See, first you find Q1, then you find IQR. For that, you will need Q3 also. So find Q1 and Q3 and take the difference of that. That will give you IQR. Now you have your Q1 value, you have your IQR as well. So you will multiply it by the number 1.5 and you will find the difference of it. Here you will find the addition of it. So this is basically a constant. No, let's assume this is, let's assume we got 10. So in your data set A, B, C, D, any value which is less than 10 will be an outlier. And suppose in this Q3 plus 1.5 IQR, I got something, a number, let's say I got this value to be 70. So if my data set has a number 120, so this will be an outlier because it is greater than 70, right?
Yes, sir.
So in that case, 120.
Sir, 1.5 is equal to 70.
What I'm saying is you find out the value of this 1.5 multiplied by IQR. So let's assume I have IQR to be 10 or something, Q1 to be 20 or something. So you can calculate the value, right? 1.5 times 10, 20 minus 15. In that case, we got 5. So in your data set, any value, any observation which is less than 5 will be an outlier. Suppose I have 2 in the observation. So 2 is your outlier. Yeah, same thing you can do with this as well. So Q3, both you have to check. So anything which is greater than this, suppose I got this value to be 100 and in my data set I have 120 as an observation. So this will be an outlier because it is greater than this outlier value, right?
The minimum value and maximum value will get from the
box plot?
Percentile table, right?
No, this is not percentile
yes,
table.
Sir. Minimum and maximum and max.
Yeah. This is your maximum value. This is your minimum value.
Yes, sir. But this one, this minimum and maximum value will get from that percentile table only, no? The first and the last value.
From the data we will get it. The first
yeah,
data
from the
and
data.
the last
Yeah.
data.
So if I give you 2, 5, 7 like this up to 100, let's say 9900. So minimum will be your 2, max will be your 100. So from here you can calculate the range as well, right? It's 100 minus 2, 98. So like that you can, from the data you can infer many things, right?
So I have a question here. Say suppose if there is an outlier in the data, so say the minimum value is the lower outlier. So the box plot diagram will be similar to the one without any outliers, or like we had understood in the previous that we want to break the data by putting 2 vertical lines, and we can do that as well for showing the outliers in the plot diagram.
See, outliers just give you a vague representation of the data, right?
Right.
It just tells you just the minimum value is this much, and it's just a representation.
Let me assume the minimum value is, say, suppose 2, and the next value is 20. And everything above that is into the range of, say, difference of 2 or 3, right? So for 2 to 20, can I, to break the plot diagram by putting 2 verticals line, where the first value is 2, the second value is 20, and every other data say 23, 25, 28 is into that range. The difference is very small. But from the outlier to the next value is a bit huge. Say, for example, the first value is 2. The second example, if I'll put the data in if I'll write down the data, my data is 2, 20, 22, 23, 26, 28, and then 30 probably. So from 2 to 20, there's a huge gap, right? So if I want to plot this box plot diagram, so from 2 to 20, I have to put up a straight line, or I can divide that by putting 2 vertical lines in between to show that ye yahan pe break ho gaya, or is it break from here?
No, you just, in that case, your box plot will vary. Suppose it will be like this line will be this much. It can vary, right? It can be
That's
like
what
this.
I was asking. I have to write the complete plot, or I can also, break this plot by putting up 2 slash line to which shows that this is a continuous line.
Yeah, you can. According to the data, you can make changes, right?
Okay, cool. Thank
Excuse
you.
me, sir, can you solve one question? And suppose we have 10 observations and we have to find how many outliers are there. So how can we find it? Actually, in graded assignment,
yeah, graded assignment 3, there was many questions, right? There were many questions in graded assignment. Let's go to week 4. We can do this at the end of the session also, right? Let's take the concepts
Guys,
of
you
week
can
4 quickly.
ask doubts in
Yes,
PSS
sir.
and also
Please
this is
move
for
forward.
revision.
Sure.
We have
Let's
only
go ahead.
30 minutes.
Yeah. Let's take week 4. So in week 4, what we do is we talk about association, right? So see, we have studied categorical variable. We have studied numerical variable, right?
Yes.
So in week 4, what we try to do is we try to find if there is any kind of relationship between these variables. So first, what we will do is we will find association in week 4 between 2 variables. So what do you mean by association? What is the meaning of this word association? It means if there is any kind of relationship. If there is a relationship, or you can say if one variable depends on the other, like if there is any dependency, right? So first, let's talk about association between 2 categorical variables. So if there is any association between 2 categorical variables, what is the meaning of this association and stuff? Let's take an example for this. Suppose in a town, we are doing a survey. So what is the survey? Survey is on a car, on a types of car versus the gender, right? Male and female. So suppose, let's take a real life example and understand what do you mean by association between 2 variables. So let's assume I have a data. Okay. So in this data set, I've been given the gender and I've been given the types of car. Let's assume there is male who prefers the type of car. Let's assume SUV. There is females who prefers sedan. There is another female who prefers hatchback. So these are types of car and there is some data given to you. So from these data, what you will do is you will convert this data to a table which is called as contingency table. From this data set, whatever it is given to you, you can convert it to a contingency table. So let's assume my contingency table is given to me. Let's make a contingency table. Let's assume this is SUV, which is the types of car. This is SUV. Let's assume this is sedan.
What is meant by contingency table, sir?
Contingency table means you have to arrange this data in this tabular form. I'll explain what it is. Let me plot the data once so that you can relate why do we need contingency table, why we compare rows and stuff. Let's take a real life example and understand what exactly does it mean so that you can understand more better, right? So let's assume this is gender, this is male, and this is female. Okay, like this. And let's make another row, which is total. And here we are taking the total of the columns. So let's assume my data is, I'm assuming this, all right? So this is a random data that is being taken. Okay. So let's assume SUV preferred by male is 10. This is 20. Let's assume these are vague numbers, okay? I'm just assuming so that we can do some calculations. So 25 and this is 10. So what will be the total of male? It will be 40. And okay, this column is okay, we can do this anyway. So this will be 50. So it will be total here 90. It will be 20. It will be 45 and 25. So this is the contingency table that we have made from the data that is given to us. So if I want to know if there is any relationship or association between my two categorical variables. So what are the categorical variables here? One is gender and another is type of car. So why do we want to find association? Let's say the car company wants to launch a car in a town. So before launching, they will figure out, right, who will buy a car more? Will female will buy a car more, or will it be a male? So that type of analysis is done before launching a car. So that type of analysis will be done with the help of this contingency table. This is the, you can say contingency table to be a point of measure that we use. It is a tool, right? So what you will do is you will convert this into a row relative frequency table, or you can either divide it by the column relative frequency. So if you do any one, both will give the same results, right? So what you will do, if I take row relative frequency, if I convert this, what you will do is I'll divide it by the row total. It is 40, that is 40, that is 40. And I'll divide this by 50. I'll divide this by 50, 50. And I'll divide this by 90. And this one, that is the row total, right? So once I do this, I'll get my row relative frequency table. So what will it look like? Let me quickly plot it. So let's assume this is my SUV. This is sedan. This is, let's say, hatchback. Okay, so this is male. So let's assume here we got 0.25, right? If I divide 10 by 40.
Yes, sir. Point.
Okay, 1 second. My laptop just got hanged. Okay. Yeah, so 10 by 40 will give me 0.25. 20 by 40 will give me 0.50. 10 by 40 will again give me 0.25. So for female, 15 by 50 will give, I think, 0.3 something. So it will be 0.50 again, and this will be 0.20. Let's talk about the total. So total is, I think, 25 by 90. So it will be, I think, 0.28 or something. And another will be 45 by 90, again it will be 0.50. Okay, 1 second. I think there is an issue with my writing tab.
Any number you can take it.
Oh yeah, wait, give me 1 minute. Okay. Yeah, so visible, right?
Yeah, sure, sir.
Yes.
Okay, yeah, sorry for the inconvenience. Okay. Okay, so we were talking about the row relative. Yeah, so here if we divide it, let's assume we got 0.50 and here we got something 0.22. After we do this,
sir, total only no, sir.
This is total, yeah.
Sir, then 0.25 is there. 0.55 is there. Total means 0.55, 1.0.
Where?
No, he's not adding. He's not adding. He's just doing that calculation.
No, I'm not
25 by
calculating
90.
this total. Let's infer from here what we can do. So here, after making this table, you will look at the values. So as you can see, these values are different, right? So whenever you get different values, what we say, the variables are associated, right? There is some association.
Yes, sir.
Yeah, from middle, sir.
Yeah, the thing is, there are 3 columns. So whenever, okay, first thing is when we are calculating row relative frequency, in that case, what will you compare? You will columns, you will compare, right? So I have found out the row relative. In that case, I'll be comparing the columns. If I calculate the column relative, in that case, I'll compare my row, right? So anyone will work. If you go the other way around, let's say you have made the column relative frequency, that will also give you the same results. So as of now, let's stick with row relative frequency table. So now, as you can see, the values are different here. So we can calculate, say that there isn't some association. Now, many of you will say that these values are same. So how can we say? So out of this whole columns, let's assume there is another column here of some different type of car, and the values are same in that case as well. Let's assume I got 0.40 and 0.40. So if any one column will have different values, we will say there is some association. At least one column, if there is different values, we will say there is association.
Sir.
Okay, yeah.
So for row relative frequency, we have to compare the rows.
Columns.
Sir.
No. If we are calculating row relative, then you have to compare the columns. These columns, the value of the columns. So let's assume every value.
Both the
But columns with the represent, then you have to compare SUV with sedan, no, sir. That is how
No.
it
We're
works.
finding the association between this SUV with the male and female. So what do I mean by this? Let's assume.
That means male has a row and female has a row, right, sir?
If I take
Those are
SUV,
called rows.
let's assume SUV and sedan. So what the company can infer from here is 25% of the male prefers SUV more and 30% like that. No, this is the inference. So, but in sedan, there's 50% of females preferring more sedan.
Associated means the values must be close.
Yeah, if you get different values, then you can conclude that there is association. So see, sedan has the association of 0.50 and 0.4. This is proportion, right? So if I convert it to percentage, that means 50% male prefers sedan and 50% of the female prefers sedan. So from here, I cannot infer anything, right? Because the data is same.
No, sir. Actually, that is not my question, sir. My question is, male here has a row and female has a row, whereas SUV, sedan, and hatchback has columns.
Columns, yeah. They are plotted in columns. No. You can switch them. No.
They are rows, male and female column.
Yeah. No. These are your rows. And this is a column. So you can switch it. No, you can make a contingency table like this, where you can put your SUV, sedan, hatchback like this, and male and female here also. So it depends how you make. Anything is
but
fine.
then for when you are doing row relative frequency, then we are comparing two rows, sir. We are comparing male
So row
and female.
relative frequency, what we do is we divide it by the row total, which is 40 and 50, right? We are dividing it by 40 and 50. So when we make row relative frequency by dividing the row total, the comparison will be done by this columns will do. That is how the process of inferring the contingency table, right?
Then which values have to be different in order to be.
If the values are different, then we say they are associated. If the values, let's say all the three columns will have the same value, in that case, they are not associated. In that case, there will be no association. Even if one column will have different value, we will say there is an association. Because it means at least one category is one difference.
6 boxes, right?
Sorry?
If any value from the 6 boxes is different, then in association please.
No, you have to check column wise. No, this column you check the values. This column you check like that.
Okay, thank you.
Yeah.
Sir, can you please explain this once again?
Sir, suppose that
What is the
there
logic
are
of
three
values?
male, female, or transgender, or a lot of genders, sir. So how can we compare that the value is associative or not?
No. As of now, we are sticking with the male and female. So try to understand what we are inferring from the contingency table. So first, you need to calculate the row relative frequency. So after calculating the values, try to see if the values are same or different. So from that, you can make a conclusion.
I have a question here. Suppose there are three rows, M, F, and say, let us assume there is a transgender category. And for the sedan, if the value would be 0.45, 0.45, and 0.1, then in that case, we can say there is an association or there won't be any association. If you are
the
comparing
values
for
are
the sedan
different, then
data.
there will be an association.
Two variables only.
I think, okay, wait 1 minute. Let me plug in my charger. Give me 1 minute.
Yeah, sure.
I think there was a question that ma'am has explained, right, in terms of income level in the lectures where there is 3 variables, high income level, medium income level, and low income level, like that. So I think there ma'am has talked about 3 variables as well. So you can look at that example. As of now, we can, do you get the point how we try to find association between two, let's say 2 categorical
How
variables?
much difference should be there to have association?
So it depends. It's a very subjective question. So as of now, in this, there is a difference, right? 0.25 and 0.30. These values are not different, right?
Yes, sir, there is only 0.05.
Yeah. Sorry.
So there is
is
no
it-
association, right?
Voice is not good, sir.
In this case, there will be an
Sir, now
association
there is
because
no
this
association.
system has different values, no? SUV has different values. So we will end up seeing that categorical variables are associated.
Sir, but in the lecture also, ma'am had said that there was only 1% different in male and female.
Yeah, I think that is.
She said that it is not associated.
Yeah, see, that is very subjective. On some books, you'll find if the values are completely different, they will be
So what will be the
association.
point of conclusion?
No,
on
in
this one?
exams, you will not get values like, let's say, 5.9, you're getting at 5.0 something. In exams, you will not get this much close. In exams, you will get values of this kind, 0.25, 0.75, so that you can infer something. In exams, you will get this kind of data.
Okay.
Yeah, there will be not much confusion about it. Yeah.
Sir, but what will be the basis of conclusion?
How to calculate?
Sorry.
Sorry. Can you please explain how to calculate this percentage? In the
Percentage, see, first you need to divide
percentage
the
out
value
of this.
by root, right? This is the root of 350 of this row, right? You divide each value by 100.
So there's some disturbance in your voice. We can't hear it.
Yes, sir. You're having voice issues.
Okay, give me 1 minute.
You are pretty audible.
Mic.
Yes, sir, now it's clear.
Okay, so is it like okay? At least somewhat better than.
Yes, sir. Much better.
Okay, so this is how you will do, right? You will divide the values by the row total. That will give you the row relative. We are finding the row relative frequency table, right? Basically, we are talking about proportions. So it will be always between 0 and 1, right? Row relative frequency we are talking about, right?
No, sir, in my questions, they were asking about percentage also.
It's multiplied by 100. No, if I get my row relative proportion to be 0.25, what will be the percentage? 25%, right?
Oh, okay, sir. Okay.
So this is what contingency table does. We can make the contingency table, and from that, what we can infer is if there is any association between two categorical variables. That's what contingency table gives us. Let's go ahead and talk about association between two numerical variables.
Sir, 1 second, one last doubt.
Yeah.
Sir, in the above one, what will be the basis of finding out the final association? Means what is the basis? If
The
two values
that
are same or what?
Yeah, if the two values are same, then there will be no association, no? But you can infer from that.
Okay.
Yeah.
So if two values are in some proportion, then we say that they're associated.
Yeah, if the values are different, then you can say that this categorical variable has something to offer. Let's say the proportion is 0.25, 0.75, and there is some association you can say, right? Male has 0.25 proportion and female is 0.75. From that, I can infer is that females buying a particular car, the percentage is 75%. So there's a more chance of female preferring a particular type of car. That is the association or dependency that we're talking about in real life scenario, right?
So for sedan, it is same for both male and female.
Yeah, but we are talking about the association in general. Like
okay, in general.
Yeah.
Okay.
Sir, so if there is a big difference, then there is very much association between them.
Yeah.
Okay.
There is
so, sir, in case of the second example, both stand at 50-50. In that scenario, we say that both the means male and female both are same consideration towards the sedan. Is that so what we speak, or we speak otherwise?
For that particular variable sedan, there is but the overall data, if we see, then there is a association between gender and type of car. That's what we will conclude at the end, because there are some columns where there is variation. Yeah, overall. Like I said, if all the columns are same and one column there is two different values, then at the end you will say there is a association, because at least one category is making a difference, right? So the conclusion will be the variables are associated. That is the conclusion that you will make, even if one category is making a difference. Yeah. Okay, so let's go ahead to numerical variable.
If we got 0.22 or 0.27 in a column,
that's
then
what
we
I'm
will
saying.
consider
In
as
exam, you will not get such kind of data. We will give a proper data where you will able to find out the difference, right?
Okay, sir. Excuse me, sir. Sorry for interrupting.
Yeah.
Sir, in week 4 graded assignment, the last few questions, the way they have solved the last few questions, I don't think that's the appropriate way. And
okay, we will solve it then. We can solve it at the end of the session.
TA section, 8 to 9, 8 to 10.
Yeah. Okay. So numerical variables.
So one simple question, sir, from my side.
Yeah. Okay.
Sir, if we calculate row relative frequency, okay, sir. After that, compare with column, isn't it?
Column wise, we will column. Yeah.
Sir, can you scroll up? Yeah, just 10 only.
And you have done this.
Yes, sir. I want to take screenshot.
Okay.
Sir, is this associated?
Sorry.
Okay, sir. Yeah.
Done, sir. Continue.
Okay, so let's go to numerical variables. So in numerical variables, we mostly take what we call as linear association. Here we talk about linear association. In this course, we will mostly focus on linear association. So the first measure that we use to find out if there is any kind of association between two numerical variables is covariance, right? So what is the formula for covariance if I'm talking about population covariance? Can you tell me?
X bar minus xi.
Sir,
into
summation
y
of
bar
x,
minus
xi
y.
minus
xi
x
minus
bar
x
into
bar
y minus y bar.
Divided
N, right?
by n.
If I take sample, then n minus 1.
X1 minus mu.
Summation of xi minus x bar by into yi minus y bar upon n minus 1.
Okay, so do you have any doubt in sample? Why do we take n minus 1? And in population, why do we take n?
Yeah, it is not
Yes, sir.
clear.
Actually, for the variance also we take the same, sir. N minus 1. Not
We take a
Because
subset
Can you
of
explain
Sir,
population.
you please tell.
Okay, so see, the answer to this question is you will learn it in statistics too. So that's my answer. So as of now, if I tell you the answer, then you will not be able to repeat anything.
And we take n, and for sample we take n minus 1.
Yeah. The reason why we take, you will be able to understand when you will be taking the course statistics 2 in your second semester. That's when you will learn in great detail why do we switch to n minus 1 in sample, and in, yeah, that's my answer as of now.
Is it because I'm just guessing? Is it because sample will be a part of population, and that's the reason it could be anything but less than n? So we are taking n minus 1.
Yeah, that is some satisfaction.
It is the whole number. That's why.
That is some satisfaction you can give yourself that yeah, sample is a subset of population, so we take yeah. So as of now, let's not switch to that because it
Is
will
it
be a
for
lot of.
safety? Is it for safety reason?
As of now, please trust us that it is a correct formula. So you will calculate with this.
Okay.
So yeah, let's go ahead. So yeah.
So,
Yeah.
I actually have a doubt, sir. Whenever I'm solving questions related to covariance, I'm getting confused if it is related to population or for the sample, sir, if it is not
Okay,
mentioned
so-
in the question.
Okay, correlation coefficient we haven't covered. As of now, we are sticking with covariance. So once we will reach correlation coefficient, we will discuss it.
Oh,
We'll
cool.
discuss everything. No worries.
So,
We will discuss everything.
the class marks are given, for example, and for example, class width is given. We have to calculate the class marks. And after calculating the class marks, we are calculating the standard deviation. In that case, the sample standard deviation will be will have n minus 1 in the denominator.
Yeah,
as
sample,
well.
whenever you get the word sample, you will take n minus 1.
But if it is not given, Sam?
No, it will be given. It will be given. It will be given. It will be mentioned clearly is if we are finding population or sample. So it will be clearly mentioned in the question.
Okay,
sir.
Okay, yeah.
How we denote population covariance?
Population covariance. Okay, yeah. So I think for this you use S, and for this you use this sigma.
Roger.
Standard.
Okay, so
Association between categorical variables.
sorry.
Can I just show the association between categorical variables?
This one.
So here it is fully based on only row and column relative frequency rate. No other criteria.
Contingency table is the point. Is a tool that you will be using for association to find out association between two categorical variables. So there are various tools. In numerical variables, we will take the help of first is covariance, and second we will be talking about correlation. So why do we need correlation? We will be coming to that. What's wrong with covariance right now? So why covariance cannot tell us so something that we have to switch to correlation? So let's talk about that. So why do we need another measure that which is correlation, right? So have you thought about it? What's the issue with covariance?
It has units.
Okay. Okay, so what's the formula for correlation?
It can be negative also.
Is it sigma xi
R is equal
minus
to
x bar into
summation of
yi
x
minus y bar?
upon root summation of x minus x bar whole square into
Covariance
root
upon
summation of
SX and
yi minus
XY.
y whole square.
Right. So let's take two numerical variables. Let's assume I'm taking two numerical variables. Let's assume this is the unit Okay, this is X and Y. Let's talk about this is the unit of X is, let's say, in kg.
It's
Let's say-
covariance divided by standard deviation of
that's what the formula is. After you put all the values in that, you will come to this formula. This is the end product. So let's assume I'm talking about two numerical variables, and the units are, let's say, X has unit kg and Y has the unit meter, and I have another data set where there's another numerical variable X and Y, and here the units are, let's say, both in kg. So when I will calculate covariance, so what is the formula for covariance? It is xi minus x bar, yi minus y bar. Let's say, and I'm talking about population covariance. So here the deviation is in products. So the unit that you will get in this data set is kg into meter, right? Here you will get kg into kg, which will be kg square.
kg square.
So can you compare these two units and draw some inference, kg square and kg? What inference can you draw right there?
Meter per kg, nothing.
So that is when the correlation comes into play. That's why.
For the qualifier exam, we don't have to learn any Excel commands, right? Like spreadsheet commands.
It's just for to give you some hands-on Excel sheet, how to use it, how it looks.
I have a question for that.
Yeah.
Okay.
So there will be no
Sir,
questions related to Google Sheets, right?
Sorry?
Google spreadsheet questions won't be there, right? Means like
No.
that.
Google spreadsheet questions won't be there. This is just for reference.
Sir, I have a question regarding the correlation factor.
Okay.
The correlation. So he was also in the graded assignment. So which range of the coefficient of correlation can be deemed as low? I mean, low, medium, moderate, or high? He was also in the graded assignment.
I'm coming to defining how the range will be of correlation coefficient and whatnot. So as of now, I gave you the reason why we have arrived this in why we need correlation coefficient. The reason is here there is the ratio, right? So xi minus x bar, yi minus y bar divided by summation xi. This is standard deviation, right?
Yes.
So the units will get cancelled. So it is a unitless, right, correlation.
Yeah.
So here the comparison will be good because there's no units. In the earlier case, there was kg meter and there was kg square. So the comparison is invalid in that case. So that's why correlation coefficient is used in order to find some correlation.
So we will have to use correlation, not covariance.
So I gave you the reason why we have come
So
up with.
I'm asking, sir, like
No,
so
in
that,
question, whatever value is given to you, you need to calculate accordingly.
okay.
Yeah. So now let's come to the range of correlation coefficient.
Sir,
So what is the range?
Correlation coefficient has a square unit.
What is the range of correlation coefficient?
-1 to 1.
Close bracket
-1 plus 1.
Yeah. Now, based on the value of
Yes, sir.
R, we can break the range, right?
Right.
Yeah. So if I break this, let's assume I'm breaking it like this. So this is 1, this is -1, and this is 0. So here I'm taking minus 0.25. Here it is 0.25. Here it is 0.50. 0.75 minus 0.50 minus 0.75. So if I take the range, let's assume from minus 0.25 to 0.25. So what will be the association in this case? Is there any association?
No association. No association.
No, right? So there will be absence of linear association. Okay. Now, if I take the range, let's assume I'm taking from 0.25 to, okay, I took this one, right? Next I'm taking 0.25 to, let's assume absolute value I'm taking 0.50. So it will be how much? It will be weak.
Positive association.
Weak positive.
Weak and positive.
Yeah. No, I'm taking absolute, no? I can break this into two types.
Why there is a absence of linear association between a -0.25 and 0.25, sir?
Okay, we're coming to that. Wait. So if I define it, so this absolute value can be, I can break it into like this. No? So here it will be weak and, okay, this is negative, right?
Negative.
Weak and negative, right? So if I break this like this, so this is weak and positive. So this together I'm writing like this. I'm taking the absolute value. Are you comfortable with me taking the absolute value?
Yeah.
Yes, sir.
Okay. So next I can write like this. Absolute value of R less than 0.75. So it will be moderate, right? And if I get the value of R to be 0.75 less than or equal to less than 1, in that case, it will be strong. Now, if I give you a value, let's assume, I give you a value, let's assume 0.89. What will be the association?
Strong positive.
Strong
and positive.
All the value is positive. And the value is
So
more than.
can you mark the like areas where it is weak, moderate in the above graph which you drew, sir? Like
Yeah, let's do it
-1
again.
to 1.
It's -1, it's 1, 0, it's 0.25.
How it is weak in between 0.25 and 0.50, sir? Please explain, sir.
Okay, wait. This is 0.50 minus 1.
Sir?
So, see, this is 0.25, right? So here what we say, there is absence of linear
Association.
really absence is there. So up till here and here, we say weak. Here we say moderate. Here also moderate.
Negative.
Yeah, we can write moderate and positive. Weak and positive. Here it will be negative. Negative. So here it
Sir,
will be
in every
strong.
question, like we have to say like positive moderate or positive weak or negative moderate or negative weak or negative strong or positive strong.
It depends on the options. If the option says strong and positive, you select those options.
Okay, sir.
Yeah.
Sir, and this R which is there, that is the correlation, no, sir?
Yeah, correlation. It's
Oh.
basically the linear relationship. So let's assume I'm giving you a question. Let's assume I give you my R is 0 and I ask you the question, are my variables independent?
Yes, sir.
Yes.
Is it
Yes,
a
sir.
yes or is it a no?
Yes.
No, sir. No, sir.
They are independent because there is absence of linear association.
There is no association.
Sir,
Okay, I'll give you another question. I'll give you another question. Are my variables linearly independent?
Yes, sir.
Yes.
Yes, sir.
No.
Yes, sir.
Yes, sir.
Take maybe 10 seconds and think what will be the answer in both the questions. Are the questions same or it's different, or what do you think?
They are linearly. The second
They're
question
different.
is
Friend question.
So this
Questions are
R, as
different.
I said, is talking about linear association. So if I say my variables are linearly independent, then R is 0. That is absolutely yes. But here it is saying variables are independent. So it might not be, because we have not mentioned if it is a linear relationship or not. I might come with the variables, two variables, which will be like this, x squared plus 5x plus 7. In this case, these two are related to each other, but they are not linear.
Yes, sir. Got it.
Yeah. So if I tell my variables are just independent, then you cannot conclude that the value.
Hello, sir.
0. Yeah.
Sir, 8 p.m. the math session, sir.
Okay. Anyway, this session is being recorded in YouTube. It will be uploaded. So when you get time, you can watch the session, recorded session.
Sir, how can we say
Okay,
that
sir.
independent and linear independence? Like,
see, first
can you
thing,
explain?
R denotes linear association between y and x. So it will be like this, a linear association, right? Something like straight line and stuff. So when I'm not mentioning my variables are linearly independent or not linearly independent, in that case, we cannot say directly that there is a independent or not, because I can come with this relationship, no, y equals to, these are related, but they are not linearly related, but they are related. So in that case, I cannot say y and x are independent, because see, you can find some relation between them, no, there is some association. So if I say my variables are linearly independent, then in that case, it will be yes, because R is 0 in that case. So I can give you another statement. Let's say I'm telling that if my variables are independent, then R is 0. What will you say?
Yes, sir. That would be
It's
absolutely
yes. Yeah, it's always yes. But if I give you from this to independent, then it might not. There'll be two cases. Are they linearly independent or they are just independent, right? So if it is linearly independent, then it is yes. If it is just independent, then I can get a relation like this, no? Or maybe some quadratic, or maybe some polynomials of higher degree. Those are related. Then I cannot say.
Can I leave if I don't have any doubts, sir?
Yeah, you can leave. You can leave the session.
Sir,
Thank you.
That is
Sir, I have
best
to
fit
leave
of
because it's
line
math session.
equation
I have
in
one
the
quick doubt, sir.
qualifier.
Sir, is this sufficient, sir? Like, whatever you teach us, is this sufficient now, like for qualifiers?
Yeah, I mean, you are mostly covering the main topics right?
Okay, sir.
Also,
So
you must have watched the lectures also, right? And are
okay,
you
sir.
attending mock questions, mock 1 and 2?
Yes, sir.
Yeah.
Mock question is very tough, sir.
Tough.
Sir, I have one quick doubt, sir. Sir, am I audible?
Yeah, you're audible.
What are
In
total
point
marks of
biserial
qualifier?
correlation coefficient.
Sorry,
Bro,
can you-
please wait. Sir, in point biserial correlation coefficient, for a standard deviation, if question does not say anything about its sample or population, in general, what we have to take? Because there is one
Generally,
question in mock.
does not say, then you will take population standard deviation.
Okay.
Yeah. So we are coming to association between.
Excuse me, sir.
Yeah.
Sir, so in
Sir, this would be the last topic
linearly,
for week 4, no, sir?
Yeah. Mostly we are covering the association between the variables. So last association is left, which is between categorical and one numerical. Yeah.
Okay, sir. Thank you, sir.
Yeah.
sir, so for linearly independent, R is equal to 0 always, and for only independent, R may be 0 or may not be 0.
Yes, for some, if I say just independent, then I can find some variables in which they might not be independent, right? Because this case, the quadratic case, these variables are related, right?
Yes,
case,
sir, yes.
They are not independent, right? So we have to
Yes.
mention whether it is linear or not linear, because R always signifies linear association.
Sir, so independent means
Yes,
that
got
there's
it.
no equations. I mean, they are. Sir, so independent means that
Independent,
like
if I
there's
some value of a variable, will it affect the other variable or not? That's what independent means, right?
like for example, if y equal to x plus 1, so in that x is independent of y, so it's like that, sir.
In this case, okay, what is the, okay, is this a linear? It is linear, right?
Yes, sir.
So in this case, if I increase x, so what will happen?
Sir, y is dependent, but x is independent of y.
X is independent, yeah. So this is a linear relationship. What is the value of R? We'll look at the slope, right? So R is 1. So there is a strong linear relationship. So by strong, what do you mean? If I increase 1, the other will strongly increase.
Okay, sir.
I give you y equal to minus x plus 1. So in this case, what will happen?
Negative. Sir.
R is minus 1.
Minus
so if I
1.
increase x, y will decrease.
So even this is
How
strong.
they are. Yeah, this is strong, but it is negative.
Okay.
Yeah.
Sir, so if they are independent, so then there won't be any equation itself, or?
No, what I'm saying, my statement was like this. Wait, let me show you.
Yes, sir. I mean, I followed you, but yes. Sir.
So my statements were, if I'm saying my R is equal to 0, can I say my variables are independent? In general, I cannot say, because I'll find some relation between y and x. This is a quadratic relation. I can say that my variables are linearly independent. That will be always, if I give R equal to 0. In that case, they will be linearly independent.
Yes.
But I cannot say if my R is 0, my variables are just independent. I can find some relationship between them. Such example is this one, y equal to x square something. Or you can come up like, let's say y equal to x cube or something. Some relationship might be there. We cannot generalize. That's what my point is. Yeah.
Okay, sir. Thank you.
Sir, is best fit line equation in the qualifier?
Sorry?
So the best fit line equation.
Yeah, I'll come
Yes,
to that.
it is in the qualifier.
Yeah, I'll come to that. I'll take it in the last. Okay. So association between one categorical and one numerical, the tool that we use is point biserial, right? So this is a point of measure for biserial coefficient, which if you note it as B.
Yes, sir.
So this tells us about if there is any association between one categorical and one numerical. So let's say I'm taking two cities, Delhi and Mumbai. And I'm talking about a new car that will be launched in these two cities. And there are some data given to you. So this city, which is your categorical variable, and then there is the sales of car in, let's say, INR lakhs or something. This is your numerical variable. So let's assume Delhi has the sale of, let's say, 5, Delhi has 6, like that. The data is given to you. This is some random data. I'm just taking an example so that you know how to apply the formula. So the formula for point biserial is y0 minus y. This on this on the root of this. So as of now, we are taking the population standard deviation. So first you need to assume the values, right? So let's assume I'm taking Delhi to be 0, and I'm assuming Mumbai to be 1. It's just a number that I'm assigning to it. So first we will calculate the average value of them, right? So if I calculate y0, which is Delhi, so I'll go back to my data and I'll find the numbers that are associated with Delhi. So there's 5, there's 6, and there's this 1. So what will be the mean in this case? It will be 6 plus 5 plus 3, 1, right? Okay, 1 second.
I guess both.
Yeah, so it will be, the average will be, I'll add up all the values of Delhi, which is 5 plus 6 plus 1 divided by the number of times Delhi is 3, right? So it will be 4. Similarly, I'll find y1 bar, so it will be Mumbai, which is 3, 3. It will be 3 plus 3 upon 2. It will be 3. Next, what we will do is, we will find out the proportions, which is P0 and which is P1. So how many times out of the total Delhi has occurred? So there are total 5, and out of this 5, the number of times Delhi is there is 3. So what will be the proportion? 3 by 5, right? So if you calculate just 1, the next one we can do is 1 minus P0. So just 2 by 5. Next, you need to calculate the population standard deviation. I think you can do it very easily. The data is not very big, right? You need to take the whole mean and then you will find the deviation, you square it and take the square deviation. So that is something we can do very easily. So then you will.
Is it like standard deviation of the right side of the
standard deviation? Right? Yeah. So it's like, yeah. So okay, 1 second. The laptop is.
Can you show the data? I can calculate.
Okay, 1 second. Yeah. So the data is 56313.
Sir, here only we have to find the mean and then we will deviate it from xi minus xy and summarize it only.
Yeah, you will add all the values and you will divide it by this. You will find the and you will find the deviation and then you will go.
1.74.
Yeah, so this can be done, right? This is something you have been calculating all in week 3, 4, right? So
it's 1.74.
So I have a doubt in the variance. So in the one question there, in multiple questions there are this that one value is wrongly noted.
Yeah, we will take those questions. Yeah, we can discuss them. So the value of this is again y0.
So the discussion will also be available on YouTube, right?
Yes. So now we have calculated this value. We have calculated this you can calculate. So you can get your value. Now the thing is, I have taken Delhi to be 0, right? And Mumbai to be 1.
Right.
So here Delhi, I got y0 bar is 4 and y1 bar is 3. So someone might take Delhi to be 1 and Mumbai to be 0. In that case, the value that they will get is 3 minus 4 in that list, like this. So in that case, the value of this will come out to be negative. But for me, it is coming out to be positive. Because population standard deviation is always positive, and this is a square root, which is always positive. So this value depends on this part. So that's why everyone will get different kind of value. So that's why we will ask you what is the absolute value of point biserial. So what you will do is whatever value that you will get.
DY Patil University continue करेंगे. MGR University में जब move होगा तब करेंगे.
Can you mute yourself?
I'm so sorry.
Yeah. So in the end, in exam, what we will do is we will ask you what is the absolute value of point biserial. So what you will do is whatever value you get, so let's say you're getting -2, you will take a modulus of it and you will write the answer to be like this. Someone is getting 2, in that case, you will take this, it will be same, right? So because of this sign, we will be asking you the absolute value.
So here we have taken 0, 1, and 3, 4. What if someone would have taken probably 1 and 8 or 2 or 1? Is it like something defined that we have to take in a continuous numerical order? Or like
no, you just you can assign any value you want. Yeah, I took Delhi to be 0 and this one.
I understand. What if I would have taken Delhi to be as 2 and Mumbai to be have taken as 5?
Then it doesn't matter.
The value will be different, right?
Just
it's as per your convenience actually.
Yeah, it's as per your convenience.
What is range of point biserial correlation coefficient?
Yeah, the range will be, on some cases you will get negative and some cases you'll get positive. So the range that it follows is the same as correlation coefficient. So it will be.
So sir,
-1 to 1.
Yeah.
1.
Same thing. And the expansion is same as correlation coefficient.
Okay.
So sir, you have shown that 2. Okay. So there is not possible to find a 2.
Sorry?
There is no possible to find a 2 that you have shown above. More.
Two, sorry. No, what I'm saying, I'm just giving you a value, I mean, example of how do you take absolute value. So you cannot get this value to be 2, right?
Okay.
Cannot be 2, of course not. It will be between -1 and 1.
Absolute value is always division,
absolute
sir.
value is when you take a modulus of it and it will give you a positive value, right? Always.
So the final expected answer should be always positive only, right?
Only if the
Modulus.
question says what is the absolute value. You have to understand, right? If it is telling you to write the absolute value, only then you will take the modulus of it and you will type the answer as positive answer.
But in exam, like I'm just curious. So if say for example in such situation in exam, if they tell me to write down the this value, if it is not mentioned absolute value, then I can write either positive and or negative. Any of these will be true, right? Or I have to write down the absolute one.
It will always mention absolute value. Always.
Okay.
It will say find the absolute value of point biserial.
Okay. Thank you.
Yeah. So there was this. There was a thing that good fit and something capital R square is there, right?
Yes, sir.
So
Can
can
you
you tell me?
scroll up your slide for a bit? I guess I have a confusion. Let me see the solution for that I can ask.
Yeah. Which one?
Slightly above. Yes, this here, right here. So PO and P1 is the number of times this may occur, okay, and the solution for this. Okay, so now my question comes up is, say for example, if as I asked you earlier that say for example I took Delhi as 3 and Mumbai as 8, then my value may comes up greater than 1, right?
No, these are the values that we are assigning in the formula, right? So in this formula, the formula is this one, no? Y1 and this. So this 0 can be assigned to either of the categorical variable. But this is how the formula is. This is just a notation that represents the value of that particular categorical variable. So if you are taking Delhi to be 1, you will put the value here, no? Because Y1.
Okay.
Yeah, that's it. It's just a representation of the particular categorical variable. There are 2 categorical variable in this side. So which one are you assigning? So according to that, you will put the value, substitute the value in the formula.
Okay. Let me practice a bit first, then maybe I come up with some other doubt.
Yeah, sure. Yeah.
So,
yeah.
So suppose we have a data like in the company according to the gender and salary, like we have to make we have to find this violation of
point by
this
serial.
thing.
Yeah.
Yes, sir. Between them. So, sir, can we take 0 as 1 as like gender and salary, right?
Yeah, you can assign male to be like say 0 and female to be 1, right? Anything you can take. Or someone will come and say male to be 1 and female to be. You assign any value. It's just in the formula you have to put those values in this. So if I take this assumption, I'll put the mean of male to be here, and female to be in this part, and rest is same, right?
Right.
Yeah, that's just a substitution. I'm just assigning categorical values.
No, I understood. I'm so sorry for such a silly.
Yeah, sorry. Okay. No, it's okay. So there is another thing, capital R square, right?
Yes, sir.
So first, let's talk about the range. The range will be from 0 to 1. So this is just some extra content. This is not something you would, let's say, not in detail we will talk about. It's just that R square basically talks about the proportion of variance in your data set. For a, let's assume.
Sir, this R square thing wouldn't be asked, right?
Not in detail. We can maybe ask simple problems, variable that is explained.
Qualifier will be of total how much marks, sir?
See that I don't know. You have given your mock, right?
Yes, sir.
So if
marks
you can
of
see
qualifier added in grades, sir.
What do you talk mock? Are you talking about mock?
Marks of qualifier exam added in grades. Total CGPA.
Yeah. Qualifier marks will be your quiz one, I think. That's how it is framed, right? So
for now, let's continue with this topic. Then after the topic, we can discuss about this.
So R square is, it gives you
this question.
Fit is goodness of fit. So what it means is, let's assume I got the value of R square to be 0.50. It means it talks about 50% variability. That's how the talk about the variability. So
What is capital R square?
It is basically the fitness, the line fitness, goodness of fit we talk about. It's how fit or how good is
And
the line.
how we calculate that?
See, calculation is not in this course. For instance, what we do is you square the correlation coefficient, and that's how the things are related in this course.
Small r could be
Yeah,
equal to r.
square it, and you'll get this.
Okay.
So
R is nothing but an absolute value of r, right?
Correlation coefficient.
Yeah, you
Absolute
square.
value of relation is r.
Yeah, yeah. So if I take two variables, let's assume y is dependent. Let's assume this y is dependent. Let's take weight of a person, and x is, let's assume, independent. In that case, let's take the age. So age is independent, right? So, but weight depends on age. As age increases, the weight varies, right? So it depends on with age. So in that way, this r square gives you some goodness of fit or something like that. So if I take r square to be 0.87, it means that 80% of there is 80%, let's say, variability or in your data set. That means varying this variable, how much this variable is moving or something like that. So it talks about how the graph is basically, how it is varying basically, right? So it is explained by your independent variable. So this talks about this. So if I increase or decrease this gets affected. So if I give you two graphs, let's assume this is another graph and this is one graph. So which is a good fit? So it depends on the r square, right? If I give the r square to be, let's assume 0.51 and r square to be, let's say 0.99. So in the range, the one closer to this will have a good fit, more good fitting. So like that, you can find the value. But the thing is, you will not be given the formula of r square to calculate because that is beyond the scope of this course. As of now, just know that the range of r square is between 0 and 1. And the thing that it tells us is the goodness of fit. How fit
the r square value, which is closer to 1, it is good fit, more good fit.
Yeah, that's it.
Okay, sir.
Will it also have similar to, like, absence of relationship, then weak, strong, moderate, what we have discussed? So will it also have similar to that, or like, is it like more fit or less fit, something like that?
That's it, just good fit, and this is just a bit introduction of r square. This is something very beyond, which is not discussed in this course.
Understood.
So just give you a small relationship, which is this. That's how we are calculating r square in this course. So yeah,
What's the unit of point biserial correlation coefficient?
Yeah, point biserial. Sorry.
Unit, sir. Correlation coefficient.
Correlation coefficient. What is the doubt? Correlation coefficient.
Unit. What is the unit of correlation? Point biserial unit means only.
Unit of, okay, you tell me what point unit.
Unit of point biserial correlation coefficient.
Will there be any unit in this?
It would be unitless.
Yeah, it's unitless.
Unitless, isn't it, sir?
Yeah. Okay, so
Sir, can you please show again that formula for point biserial correlation coefficient?
Point biserial, okay. Yeah.
Sir, so our topics are over now, week 3 and week 4.
Sir, here is a
overview of
standard deviation.
Sorry.
Sir, here below y bar minus y naught bar minus y1 bar.
Population standard deviation. Yeah.
Standard deviation. Okay. Population standard deviation. Right.
So, do you have any doubt in maybe any of the grade assignments or anything? Then you can ask.
Sir, I have just a small doubt. When 5 observations are given and its mean and standard deviation is given, so one observation is wrongly typed as another one. So how the standard deviation, what will be the new standard deviation? So like that question.
So it depends. You have to say it depends on the data, right? How it is. And so what you're saying is mean is given to you.
Yeah, sir. Just 5 observations are given. Mean and standard deviation is also given.
Okay.
And one observation is wrongly typed as another observation.
Okay. Yeah, this is a assignment, right?
Yeah.
So maybe we can solve it. Give me the data. Maybe we can solve it.
Sir, just we can take a random data. Actually, I don't have any data now.
Okay, so let me maybe take the data. I think there was a, okay, let's assume, let's take, maybe we can take mean to be, let's assume we take 19, and let's assume the sample standard deviation is given to be 11.
Can you solve graded assignment 3 question 2? Like, the person is asking.
Okay, graded assignment week 3, right?
Week 3, question number 2.
Question 2, okay. So was it the incorrect mean in this?
Yeah, the question says that the mean and the sample standard deviation of the data set consisting of 10 observation is
Okay,
16 and 10 respectively.
16 and 10, right?
Right.
Yeah, then what observation?
Later it is noted that one observation 16 is wrongly noted as 10.
16 wrongly noted
as 10.
Okay.
So what is the mean of the original data set?
Mean and samples.
Yeah,
Yes,
what is
sir.
the mean and the sample variance of the original data set?
Yes, sir. Sir, I can find out the mean. I can find out the mean, but how can we find out the sample variance?
Sample variance, right?
Let's solve this question then. Okay, so if I write the formula for mean, it will be the formula for mean, sum of all observation upon
Total number of observations.
Total number of observations. So let's assume for this incorrect data set, incorrect, the mean is given to be 16 and the total observation is 10, right? So we can calculate the sum of all observation in this case. So what will be the sum in this case?
160.
Sum of all observation will be 160 into 10. Basically, we are cross multiplying this, so it will be 160. Now, this is a sum of all observations. So in this observation, the data that is wrongly noted is also there. So what we will do is we will subtract the data which is wrongly noted, that is 10, right?
Yes, sir.
Then we will add the correct data. So this is the wrong observation and this is the correct observation, right?
Right.
So now we will get the correct sum. So it will be 160 minus 10 plus 16. It will be 160 plus 6, 166, right?
Right.
Yes, sir.
So now if I calculate the mean, it will be the correct sum of observation, which is 166. And it will be divided by 10, right? So it is 16.6.
Right.
So are you getting this step why we are removing one observation and adding one
We
observation?
agree
Yes,
with
sir.
this. We
Yes,
want
sir.
to understand how we can calculate the deviation or the variance part of
Sample
yeah.
variance. Yes, sir. I'm getting problem in the sample variance.
Okay, so do you know this formula for sample variance? Summation xi square upon n minus 1 minus n times x bar square upon n minus 1. How many of you know this formula?
Sir, I think it was not explained in the lecture, but I mean,
So do you want me to derive this?
11 it is there, sir, I think.
In some of the open session, it was shown, but not in, but it is not shown in the lectures actually.
Okay, yeah, in lectures this is not discussed. Okay, maybe I can derive it for you. Give me 1 minute.
Yes, sir. Yes, sir.
Yeah.
Can you just explain what does each term mean?
I'll explain everything. Yeah, this question I'll solve it. Wait, give me 1 minute. There's some issue with my device. Give me 1 minute.
No problem.
Yeah. Okay, it's good now. Okay, let me share my screen. Okay. Yeah, so it's, can you see my screen now?
Yes. Yes.
Okay, so I wrote the formula of sample variance as like this. Xi square upon n minus 1. So this is sample variance minus n times x bar square upon n minus 1. So how do I get this formula? Let's write the actual formula that is being taught. That is xi minus x bar whole square upon n minus 1, right?
Hello.
Right.
Yeah. So what will I do is I'll keep this 1 upon n minus 1 as it is. I'll expand this whole square. I can open this a minus b whole square formula, right?
Right.
Right.
So what will I get? Xi square plus x bar square minus 2xi x bar, right?
Right.
So I'll keep this n minus 1 as it is. So I'll take the summation inside. So summation xi square plus summation x bar square minus summation 2xi x bar. Okay. So now what will I do? Again, I'll keep this as it is. summation xi square plus. Now see, x bar is what? It is mean, right?
Right. So it's become nx bar.
Yeah, x bar square is also square of mean. So this is a constant, right?
Right.
This constant will come out from the summation.
Right.
So it will be x bar square. Now summation of a constant, if I take I from 1 to n, what will be the value of this?
Nx bar.
That will be n, right?
N, right.
Yeah, again, this 2 is a constant, I can take it out. This x bar is again a mean, which is a constant, I can take it out. I'll keep this xi as it is. Now there's another formula of mean. This is x bar, which is mean. Mean is basically what? Sum of all the observation, right? X2, x3 like this.
Right.
Till xn upon n.
Right.
Now, can I write this numerator like this summation xi? I from 1 to n.
Yes, sir.
Right,
Yes,
can
sir.
do that.
From here I can get the value of this, right? Xi. It will be n times x bar.
Yes, sir.
So can I substitute this value of this on this part?
Right. We can do
It will
that.
be how much? N times x bar, right?
Yes, sir.
So now the formula will be 1 upon n minus 1 summation xi square plus
X bar n.
x bar n minus 2. It will be, no, it's x square. No?
N into 2n square x bar.
Minus nx bar square.
Wait, show it my device. Okay. Yeah, it's x bar square n minus 2 times. Yeah, wait, let me share my screen. Yeah, so this is nothing but this is square. This is 2 times x bar square n, right? So this is nothing but summation xi square. Now this will be how much? Minus n x bar square. So now I am multiplying this n minus 1 inside. So I will get this upon n minus 1 into n times x bar square upon n minus 1. This is another formula for variance.
Okay.
So we are deriving it in order to solve this problem. So now see, we are given with sample standard deviation, right? In the question, the sample standard deviation is given. How much is it?
Just a second.
Yeah.
10.
10.
10, right?
Of the incorrect data, right?
Yeah. So what is the relationship between standard deviation and variance?
Sure. It's the square root of variance.
So do I take like this?
Yeah. Right.
Yeah. So if I
So minus 1.
it's okay. Okay, so variance will be 10 square, right?
Right.
Okay, yeah. So it will be 100. So if I take this formula,
You have to calculate the sigma of x square, right?
yeah. So this is the formula: xi square upon n minus 1 minus n times x bar square upon n minus 1. So
Right.
let's assume for the incorrect data set first.
Right.
So for this incorrect data set, this is 100, right? Now we have
Right.
calculated.
Right.
So if I plug in the values, this is this. I don't know the summation of xi square. I'll keep it as it is.
Right.
But n I know, right? N is how much?
Right.
7, right?
10.
10. Okay. N minus 1 will be 9. Here n is 10. N minus 1 is 9. What will be x bar square?
The old one, the wrong one.
Yes, incorrect one. So it was, I think, 16, was it?
16, right.
Yeah. So I will put here 16. Now see, x bar is 16.
16
It is
square.
x square. Yeah, yeah. So it's
16 square.
this one. So from here, I'll calculate the value of sigma I square. So it will be how much? I'll take this value to this. So it will be 100 plus 10 into 16 squared upon 9. And I'll multiply this 9 to this side. It will be like this. Okay. I'm skipping few steps.
Right.
So 100 times 9. If I multiply this to both the terms, so it will get cancelled. So it will be
Right.
16 squared. So it's 900 plus 256, 0, right?
Right.
So it will be 60, it will be 3460, right?
Right.
Yes.
This is the summation in the incorrect
Right.
one. So now, as we know, 16, 6 is wrongly noted. Can you give me the data?
16 is wrongly noted as 10.
Okay. So now in this summation of the observation from here, I need to remove 10, which is wrongly noted, and you have to add 16 square.
Right.
We have to do here. Okay. Yeah, got it.
Now I got sigma I square for the correct data set. Now write the formula again for sample variance. And -1 minus. Now the catch here is, I know this one, I know this one, I know this one, which will be this one that I have calculated from here, which will be 3460 minus 100 plus 256. So you can calculate this formula, plug in here. You know n minus 1, you know n minus 1. Now this x bar square is a correct mean. Don't substitute the incorrect mean. Yes, correct mean. Yeah, new mean maybe. Yeah.
Right.
That will give you the whole value will be your sample variance of the new data set. So that's how you will solve this problem. So the catch was this formula. This formula you should know. Even if you don't know, you can derive it, right? Now you know the procedure.
Yes, sir. Yes, sir.
Yeah,
Got it, sir. Got it.
Sir. Yeah.
Sir,
I have a doubt. We are closing the session. It's already 8:33.
Sir,
Yeah.
I have a doubt regarding this point biserial coefficient. Can I share my screen for a moment?
I think there's another session tomorrow. I think we can take it from there.
Sir, just it
Sir, I have a small doubt.
2 minutes.
We will take it tomorrow. I think we are closing the session. Yeah.
Thank
So see, there is
Thank you,
another
sir.
from instructor.
Good night, sir.
So yeah. Good night.
Okay.
Thank you, sir.
Thank you so much. This session was very helpful. May I ask your name, please?
My name is Abhilash.
Thank you, Abhilash.
Yeah.
You were very helpful. Thank you so much.
Yeah. Study well, crack the qualifier. All the best.
Thank you so much.
Thank you, sir.